Okay, so how many minutes will it take to fill the pool if only 3 taps are used? Great question. So it's taken 120 minutes to fill the pool with 5 taps. So how long would it take to fill it with 1 tap? It would take 600 minutes, right? 120 times 5. So then, how many minutes would it take to fill the pool if only 3 taps are used? Well, if we do that 600 and we divide it by 3, right? Because if it takes 600 minutes for 1 tap, it'll take a third of the time if we use 3 taps. So then we get 200 minutes. And the question is, does that make sense? And the answer, absolutely, it does make sense, because 200 is like a bit bigger than 120. Right? It's in the range that we're looking for, and that's an incredibly valuable tool to use when you're doing papers. And you think to yourself, does my answer make sense at all? And if it doesn't, then don't write it down, right? It seems absurdly simple, but nobody does it. So, nonetheless, let's carry on. Another way to do that, by the way, if you are so inclined, is that if you use 3 taps rather than 5 taps, it will take 5/3 of the time. Okay, that's basically what we did. We multiplied by 5 and divided by 3. That's what you do if you multiply by a fraction, you're dividing by the denominator and then you're multiplying by the numerator, right? That's all you're doing when you multiply by a fraction. That's why if you want, you're able to write it out like that. Right, so you multiply by the numerator and then divide by the denominator, or the other way around. It doesn't matter at all. Yeah, I'll tell you what, quick spicy point about fractions. Here's what I'd do here. I'd simplify it like a fraction. So that 3 I'd cancel with the 120. So I'd get 5 times 40. Yeah, it's just going to be 200. There you go. Anyway, state one assumption. You had to use loads of assumptions. We always assume lots of things in these questions. This is actually relatively easy. You just got to be willing to say things that you think are right. Okay, so with questions, when it says what is the assumption, or suggests questions or whatever, you're aiming to say something that isn't wrong. Okay, you're not trying to blow their minds. You're not trying to make the examiner sit there and go, wow, let me write them a letter to say thank you for that delightful answer. That's not what you're doing. What you're trying to do is trying to write something that isn't wrong. For example, we assume that all the taps release water at the same rate. Okay, that's one option. The swimming pool is the same size. That's another option. Stays the same heat. Are they going to like that? Probably not. It'd be correct, but we'll leave it be. We'll leave it be. Anyway, on to the next question. A plane travels at a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. Okay, so 213 miles in an hour. So if it's going 213 miles per hour, we can do a few different things. So, what would be the best way to do this? Okay, so one way to do this is to say that in 60 minutes, it's the same as 213 miles, right? 60 minutes is 213 miles in this situation. Okay, so what we're going to do is we do 60 divided by 213, we'll get the number, we'll get 1 mile, right? We'll get the time that is 1 mile. So now we've got to do 60 divided by 213. And what do we do there? Well, it's actually pretty easy because we've got this word estimate. And what does estimate mean? Estimate means one significant figure. It's easy as can be. Because when you're doing one significant figure, you are literally just using the first number that's not 0. So 60 divided by 200. What's that going to give us? We'll divide by 3 and we'll divide by 3 and divide by 0. Will we do them at the same time? I'll divide by 0, divide by 10. Take a 0 off is what I mean. Obviously, if you're listening to this in a classroom, I'm sorry, teacher. Do not take the 0 off. Don't do that. We don't do that. Not here. Not here. Divide by 3 now. It's very, very bad. It's very, very bad. Did I say divide by 3? I meant divide by 2. I was too busy hating myself because I did the wrong thing. I did a terrible thing. It just took the zeros off when I divided by 10. Anyway, this is in minutes. We want it in seconds. So we've got to multiply by 60 now. 3 over 10 times 60. And we're going to do that to the top, so we end up with 180 over 10, which is 18. And that's the answer, 18 seconds. Yeah, if you watched the last one, I think it was the last one. How long's this stream? Probably was the last video. So if you watched the last one, then here another thing you could have done then. Just as a side note, if I just drop a little box up here, if you have 3 over 10 times 60, then you can just cancel the 10 with the 60 and just get 3 times 6, which is also 18. I like that. I like that. But hey ho, is your answer to part A an underestimate or an overestimate? Give a reason for your answer. Well, we rounded the denominator down here, didn't we? So here, we rounded down. So if we round the denominator down, our answer is going to be bigger than it should be. Okay? You can check that with really simple numbers. Just do 10 divided by 2, it's going to be 5. And if you make the denominator smaller, you get a bigger answer. So what we had was an underestimate. Overestimate, obviously. So our answer is going to be an overestimate. Because denominator smaller. Okay. On to the next question. Solve the simultaneous equations. I'm going to take a break to have a drink. Lovely. Solve the simultaneous equations. Right. We can do this by substitution or just by multiplying one of the equations by something. I find it easier to just to multiply them by something. If you're going to pick one, right? If you really do not want to think about simultaneous equations, do substitution. Okay, learn substitution and just always do substitution. That's what I'd say. Is it a bit harder? Yeah, it is. But once you get the hang of it, I think it's easier. I'll do both. I'm going to treat you. Because I tell you what, they've been very generous with this paper. They've given us little lines down here. We'll do substitution. But for now, I'm going to do it how I want to do it because it's how I like it. So we'll multiply the bottom one by 5. But multiplied by 5, we get 5x minus 15y equals 45. Okay. Then I'm going to subtract the bottom equation. No, I'm going to subtract the top equation from the bottom equation. So the top equation is 5x plus y equals 21. So we do 5x minus 5x is 0, minus 15y minus y is minus 16y, and then 45 minus 21 is 24. So we get minus 16y equals 24. So if we take that minus 16 over, we end up with y equals 24 divided by minus 16, okay, which is 1.5. So y equals minus 1.5. Okay, then we're going to pop that back into one of these equations. Let's go for the bottom one, because there's not a number in front of the x, it'll make it a bit easier. So we pop it in there. X minus 3 times minus 1.5 equals 9. So minus 3 times minus 1.5 is 4.5 positive. So x plus 4.5 equals 9. Take that over. So we end up with x equals 9 minus 4.5. So x equals 4.5. Okay. So x 4.5. Y minus 1.5. Now, let's see if I was wrong. So, if I just pop the equations back down here, I tell you what I won't. I'm going to put one equation down here, 5x plus y equals 21. The other one I'm going to use for my substitutions. I'm going to rearrange it slightly right off the bat. So I'm going to make it x equals 9 plus 3y. Okay, why did I do that? I did it to get x on its own. Okay, so when you're substituting, you want to get one of the variables, either x or y, or if the exam board's being quirky, whatever letter they choose, probably x or y though, we're going to get it on its own. So x is on its own now. So then we can put this back into the other equation, right? Because x is 9 plus 3y. It is in every situation. X is 9 plus 3y. So we can, wherever we see x, we can put 9 plus 3y instead. So we have 5 bracket 9 plus 3y bracket plus y equals 21. We expand that out, we get 45 plus 15y, 5 times 9, 5 times 3y, plus y equals 21. Going up here. So then 45 plus 16y equals 21. Let's I'm going to take the 45 over to this side. So we get 16y equals 21 minus 45, which is going to be minus 24. And then we're going to take this 16 over and divide. So y equals minus 24 divided by 16. So y equals minus 1.5. Oh, bellissimo. So, we've run out of space. Let's shrink something down. Well, there we go. The magic of technology at our fingers. Anyway, y is minus 1.5. It is actually a bit easier because we've rearranged to this to do our substitution. So it is actually a little bit easier because we've done this thing here. So 2 bonuses there. So now we can say x equals, don't need the bracket. We don't need the bracket. We're not gonna have that crutch for ourselves. 3 times minus 1.5. 3 times minus 1.5 is minus 4.5. So x equals 9 minus 4.5. So x equals 4.5. There you go. I prefer the top one. Don't know why. Personal preference. The reason why I say if you can do substitution, to always do substitution, It's because you can always use substitution, right? Will you get horrid numbers sometimes? Yes. Yes, you absolutely will, right? Sometimes you'll get horrid numbers and it'll be really hard to do the mental maths. So I apologise if that happens. But every single simultaneous equation question can be answered with substitution. Some of the harder simultaneous equation questions can only be answered by substitution. Therefore, I just always use substitution. Well, what do you know? You've made it to the end of the video. But that was only 12 plus minus 2 minutes, which means that you can now go and watch another one and you can feel extra productive. Maybe go get yourself a drink. Definitely like and subscribe. Thank you for watching and come back for the next one. See you then.